Alright, so let's talk a little bit about anti-alias flow noise, which is what I used in here. So let's make a line just to show anti-alias flow noise, and then let's increase the points to 50 and do an append attribute vol. Let's go in there. Let's maximize the view so we can see a little better. And let's put an add, because again, we're going to add something to the position. And again, that's the position for every point. And then we're going to type anti-alias flow noise. Let's put in the position, 3D noise. Let's add it in. Let's promote some parameters. And let's put the time in the flow. All right, so just let's see what this will do. So by default, if I play, nothing will happen. This is because I have no idea why this is the case, but with this specific noise type, if the offset is set to 000, it doesn't work. So if you slightly offset the offset, and if you now play, you can see I get this sort of like looping noisy motion, which is quite nice for certain type of effects. Also, for example, if you do electricity arcs, it's also very useful. Of course, you can stack this with like the regular offset stuff that we did before. So you could do stuff like this. So that's the anti-alias flow noise. And that's what we're going to use for these tentacles. So let's make an append an attribute vol after our copy to points. Again, let's make sure it runs on points. And let's dive into there. Let's make this a little bit smaller. All right. So let's just start building. So I hope you already tried this for yourself, maybe with the turbulent noise that we used before. Because you could also make this work with the turbulent noise. You're just going to use the anti-alias flow noise like this, just to show you that there's multiple noises, and the flow noise has this nice flowy motion. So again, let's put down an add. Type anti-alias flow noise. Put it in position, and with P I can open up this window. By type 3D noise, and let's plug it in, plug it into the position. Right, we need a little bit more points for every line, so let's increase the points, so maybe 50. All right, so now you can see something is already happening. So you can see right now it's just doing it all over the thing. Let's promote some parameters that we want to be able to control. Let's promote the frequency, let's promote the amplitude, let's promote the roughness, and in the flow, let's put the time in there. And then let's put a multiplier between here so that we can multiply the speed and call that speed. Speed. All right. So if I now go up and up this, you see it already works even without us changing the offset. That's because the lines are now not, so the lines aren't completely angled down straight. Like if I were to disable it, well, it still works. But if you do this on a line that's just in the center, again, and it doesn't animate. I have no idea why, but it's just something specific to this noise. So you can already see we get some movement going on. Maybe we want to reduce the roughness a little bit. And you can see the entire thing is moving. But again, we don't want the top part to move because that's what will be connected to our squid, right? So we don't want that. So if you remember how we could change that is if let's pop out the amp by clicking on it, and let's bind our curve view attribute that we have. So bind curve view. So that's the attribute that we have, remember, from the resample. So let's see. Oh, we actually don't have it here yet. It's because, of course, we have new lines now. So we kind of need to add it. So let's put a resample maybe on our line here. Let's enable curve view. And let's set our points on here instead. So 50. All right, so now we do have curve view. Now we can go in here. Now we can say, we want to multiply our amplitude by our curve u. So let's see, curve u, and for some reason it's still, all right, so maybe what we want to do is we want to calculate it afterwards, else we have to do what we did before and say that we need to also copy it to the thing, but we can also just calculate it afterwards, so it doesn't really matter in this case. Again, sometimes the order will matter, sometimes not. So if we play now, you can see they're already sticking to the thing. But we want to do a ramp parameter in between here. All right, and let's put it to spline ramp. So now it stops. And now let's put it like that. Maybe something like that. Now we can increase the amplitude and we can increase the frequency. So we're already getting something cool now. Ooh, fancy. All right, so depending on the look that you're after, this might be what you want. So right now it's sort of flowing. So you can see we get this nice sort of flowing movement. So depending on what you're after, this might be the thing, but maybe you want to do some more randomization. So remember what we can do in that case, we can type random. So what could we use for the random function to plug it in? Well, we could say that we want to put the prim number in here. And by the way, I'm not going to show this node in Vex because when working with noises, I just prefer to do that inside of FOPS. The reason is you can absolutely do this in Vex, but you need to create every single channel individually yourself. And I just think it's more user-friendly to do anything with noises inside of VOPs. So that's just my preferred way of working. Anyway, so if we highlight our primitive numbers, you see every curve has a primitive number. So if we put the primitive number in our random function, this will spit out a random value from 0 to 1 as a random number, basically. So for every curve. But we don't want it to be a float, we want it to be a 3D vector, because we can add it then to our offset. So what we can do is then maybe fit range it, so we can make the range a little bit more extreme. So let's put it into value. And you can see the colors change because float is like bluish, and then when you plug in a vector, the colors automatically change. And let's make the range a little bigger, right? So now what we can do is we can say, okay, let's plug that in. And now let's play. And now we have a lot more random movement. So again, depends on the look that you're after. You could go for something like this. It's more uniform. You could go for something like this. You could even say, so like, oh, I want it to be somewhat in the middle. Remember what we did before? We used a mix. So I could even say that I want to be, so the regular offset is 0. Let's put this as the new offset, put it into there. We have a bias. So this is the original, and we can sort of slowly mix in the other one. So you have some controls over. Doesn't actually make that big of a difference, in my opinion. I'm just gonna keep it like that. But you can just put it in between if you want that control. So just something to keep in mind. So maybe what you also want to do is maybe you want to change the speed a little bit randomly for every curve. Remember, we also did this in the seaweed. So it's like a lot of the techniques that we've been discussing are the same for this as it was in the seaweed. So that's what I'm using. What I'm meaning is that like Houdini is very logical. Like if you understand this way of working, you can apply it anywhere. So let's put this a 1D output because we want to use this as a multiplier. Let's do another fit range. Because a random function will always spit out a 0 to 1. But again, if we plug this in to here, then some will hardly move at all and some will be very fast. But if we put it into a fit range, we can say input 0 to 1. But then maybe for some reason this has the extra thing there. Let's just make a new one. I'm not sure why this does this, have this thing by default. It's kind of weird that it sort of also gets this one. That's a little bit strange. So anyway, so we can change the destination max here to be maybe, oh, sorry. I'm accidentally removing stuff. All right, let's plug this back in here. Let's plug this back into offset. And let's plug the other random. I was accidentally undoing some stuff, I think. Let's put it into prim number, one integer, put it in there. So let's change the minimum to be like that, and then multiply, put it into multiply. All right. So now they will have slightly random movement speeds. So again, you can just randomize stuff like that. So you can have control over the speed, like the randomization of the speed like that. All right, so let's just move up a level and call this, I guess, noise big, because we can copy and paste this one and just like use it another way. So let's maybe we do want this to be like somewhat big, and I think I want them to be sort of not pointed out as much. So maybe have them be pointed in a little bit more. So again, we can use the add node, position of the add node to do that. So this will be the noise big. So that's looking pretty good. Then we can copy and paste this. Add another one, maybe up the frequency on this one. And let's maybe change the speed a little bit on the small noise, maybe something like this. But again, just play around with whatever you like. Like you can just make it look the way you want it to, and I mean, it's your squid. If you want to make a completely different looking squid from the one I did, go ahead and do it. YOLO. Right, so I'm going to pop out my controls over here again. And let's see what we did. All right. So I had a resample here, which don't necessarily need, I think. I had a lot more points there, or we can just keep it like this. We can always add more, add another one later. I think up here we had a little bit less points. Let me see. No, it's not even that big of a deal. Right. So let's have a look in our original thing. So you can see we're almost at another branch. So let's have a look in what I did. So over here I had a polyframe, which again creates sort of this thing with the normals, which you can use for stuff like some orientations and stuff. And then we're branching over here to the right, and then on here to the left. So let's first maybe do like the easy thing, and let's just do this little thing, because this is something that you should already know how to do based on what we discussed already. So I challenge you to maybe try this part for yourself, just so have these weird little thingies scattered on it. So have a go at trying to make that, and then I'll come back and show it for you how to do that job, how to do it.